Welcome back. WW Fly Corvair here. We're going to get a real quick look at the structures of parasols and show you some of the factors that go on inside an aircraft like a Pietenpol air camper that make it unique structurally and why you have to pay attention to this when modifying, building, or improving, or whatever you're doing to change the design. There's factors going on that people regularly do not understand. Today we're going to take a look at these. The primary factor that affects all parasols is the wing moving in relation torsionally to the fuselage. This is the issue right here. And how is that resisted? Okay, how is it any different than a Cub? Well, a Cub is a cabin airplane, not a parasol. Well, they kind of look a little bit alike, but what would a Cub do that's any different than this? Why is a parasol subjected to this? Well, a Cub has upper longerons. The upper longerons would be sitting roughly in this place, and I recognize that's not great model building, but the upper longerons and the diagonal tubes keep the wing rigid in relation to the fuselage in a Cub. It's very different than a parasol. If you want to have a look at a Cub, go to your airport and look at that tube right there in a Cub. It's behind the pilot's head. It's one of the largest tubes in the fuselage. It will take the load in column bending when the fuselage is twisting back and forth. It holds the wing very rigid in relation to the rest of the fuselage. Again, parasols do not have this structure. They have to pick it up elsewhere. One of the things when people look at airplanes, they don't spot the structure of it. Go back and look at a Ryan M1 mail airplane. A lot of people look at that and say, oh, that must be a parasol. But what they're missing is there is structure up here. Even though it's not covered, a Ryan M1 is structurally a cabin airplane. One of the factors particular to Pietenpols is the Kabane struts are vertical or near vertical on the airplane. Many parasols have V'd Kabane struts and no center section, but this does not apply to a Pietenpol. A Pietenpol has its four parallelogram struts. It also has two small diagonal Kabanes up in the front, which would be sitting here. But if you take a look at that and study their resistance to rotation, that front strut is really just leaning over when the action takes place. You could make it very strong, and it would not stop that motion right there. What about the diagonal roll wires that are located right there and right there in a Pietenpol? Shouldn't they theoretically stop this action? Yes, but in the plans they're 3/32, and a lot of builders put tabs that are standing out cantilever slightly, and these wires cannot nearly take the load that can be generated by the full span of the wing. The fuselage is only 24 inches across and the front spacing is 29 inches deep. If you compare that to a cabin airplane, even if it was a double-wide parasol, this is a very small footprint to resist this motion, and the wires are far too small to take that load by themselves. Okay, so what does take the load of the wing trying to twist on the fuselage? Well, in a lot of airplanes, we're used to seeing V-shaped lift struts like this. But if you study this closely and think about that wing twisting, you'd realize there's almost nothing there to stop it from rotating. It will not effectively do its job. You can have this type of lift strut arrangement, but it has to appear on a cabin airplane. It cannot appear by itself in a parasol, particularly not a parasol with a center section. It doesn't matter if it's swept backwards or swept forwards. Neither one is an effective solution on a parasol, no matter how many times you've seen it on a cabin plane. So what solution did Bernard Pietenpol install on the air camper? A fairly simple one. It is a set of parallel lift struts with diagonal brace wires. The parallel lift struts are the green pipe cleaners, and the red ones are the diagonal wires. If you take a look at this and study it carefully, and try and sweep the wing forward, what you'll find out is this wire right here and this wire right here will brace these two. You could build this yourself and study it really close, and you'll see which one goes into column bending and which one goes into tension. But this very effectively resists the load on the wing in a way that a diagonal or V lift strut will not. If you look at parasols, you'll find out that this arrangement exists with V'd cabanes and no center section on a lot of parasols, like Baby Aces, and it also existed on the first models of Heath parasols. It's a common arrangement. It's actually stronger than what a Pietenpol does, but there's nothing wrong with a Pietenpol as long as you have all the systems in place and do a good job making all the subcomponents. There will be people who point out that V-lift struts appear on certain aircraft like a Heath Model V. A Heath Model V has two different features than a Pietenpol. It has V'd cabanes, as we've seen before, and no center section. The other thing is, a Heath has a diagonal brace wire that runs all the way from the motor mount to the rear lift strut attach fitting, represented in green here. This diagonal brace wire is a crucial part of keeping the wing on a V parasol. It would not work at all if you were using any other cabane arrangement than this. On a Pietenpol, the fuselage is a very, very strong unit. The wing is also very, very strong. If there's anything on the airplane that doesn't match the strength of those two joints, it's the joint between the fuselage and the wing. Doesn't mean there's anything wrong with it, just means that it has to be built according to plans or better and utilize the same load paths. This is why your cabane struts are really important structures. The roll wires and the diagonal cabanes are critical on a Pietenpol, and of course the lift strut arrangement. One of the things I've written about a lot on Pietenpols are the diagonal cabane struts that attach the front spar to the upper motor mount tubes. If you take a look at it, this is a critical structure. In normal flight, at small angles of attack, that's actually in tension. Contrary to what most people think, when you put this airplane at a high angle of attack, that actually goes into compression. But when it really goes into compression is if you have any type of an accident at all. The wing with the fuel in it has a lot of inertia. You wipe the landing gear off, misjudging a landing, and this airplane coming to a halt will try and parallel the wing forward. If you look at accident photos, there's an awful lot of accident photos with a kinked strut right there and the wing laying on the fuselage. In a mishap of any kind, the fuselage will generally hang together and the wing will also, but it will parallel forward like this in many instances. The only thing resisting that is that diagonal cabane. That's why it has to be beefed up over what's shown in the plans. There are diagonal brace wires, but I'll guarantee you they'll pull or snap. They cannot withstand this load. They can withstand flight loads, but not overloads like this. You get this gap small enough, two things happen. One, fuel lines between the wing and the fuselage get pulled out of shape and broken, and then you got spilled gas. The second one is, in a particularly hard hit, one of the things you're going to have is the front passenger is going to get trapped in the airplane, and that's a no-go. In my 2001 Pietenpol mishap, I was in the front seat. When the wing paralleled forward because I had weak cabanes, this gap got to be 10 inches tall. To get out of the airplane, I took one of my sneakers off and slithered out of there. That was about as close as you can get to being trapped. The airplane caught on fire in maybe 90 seconds from the impact. That's about as close as you ever want to get to getting trapped in an airplane. The fuel tank, contrary to what many people think, I had an integral fuel tank in the wing. It held up just fine. It was the deflection of the cabane struts and rigid lines rigidly attached to the cabane struts that pulled right here and right here fittings off. As I slithered out that hole, I got soaked in gasoline. Bernard Pietenpol designed a fantastic aircraft. With minor improvements, it can be flown with great safety today. How much respect do I have for the man? I've referred to him as the patron saint of home builds for a good reason. You can take a look at this. It sits on the shelf in my shop. It is an original cylinder from the last original that he built. How much? That's the light switch from above his desk in the workshop. How much respect? That's a coffee can of soil from the runway at Cherry Grove. I have intense respect for the man's work. If you want to demonstrate your respect for the man's work, understand the structure of his airplane and build it and fly it and do a great job. Thanks very much for giving this a look. I appreciate everybody who subscribes to the channel. If you'd like more videos like this, please just let us know, and your subscription is an important part of us being able to bring it to you. Thanks very much, and we'll see you out on the flight line.